Okay, I've gone through this. Remember, this is still a 12-inch piece, so we'll see. I'm going to keep going on this, and then we'll kind of do it maybe tomorrow or the next day again, realizing that you can kind of take your bridges there. I just picked out some basically sized, pretty large pieces of metal, the standard stock, and it made about a bazillion parts. So that said, these are different sizes. You can actually go into each individual part here if you want. Double click on that, and it kind of lets you go in eventually, and actually you can go inside of that and all of a sudden do things like I don't know, you want to put a hole in one. Well, you can create a 2D sketch in there. Right away it does that, and we're going to grab a circle, put a hole, just a little tiny hole in that one, in the one member there. We're going to finish the sketch. You can still go through and do your extrudes. Remember, you can select out. Going to grab the profile. Hopefully grab your profile here. You see it grabs that. We're going to do a cut and then hit OK. And what you've now done is you have basically, you're going to return, and you're going to return, you just cut a hole in that one. So the fact that what this is doing and what it does to Framegenerator, it's just saving you some of the hassle as you go through. And so we're not going to cut any more parts out of this. What we're going to do right away now is go ahead into the environments and go to stress analysis and make this all aluminum. Trying to find the wood. Let's see if we can make it. I don't know the wood numbers yet, so I'm going to go to just create animation here. Static. We're not going to go much more than that. These are going to be all bonded together. You're going to see there's so many parts. It gets kind of be interesting what it does with the contracts, loads, and constraints. But I'm going to turn around here and just literally we're going to add along something logical or not. We're going to add a fixed constraint along this face. So we're going to take a fixed constraint. We're going to grab the location there. We're going to click on that. We're going to hit OK. Now within that you've got a lot of different parts right now. We're going to also then add a cantilever load out on the outside. When we add a load here, again this is, we're talking about there's no we didn't turn these things in the right direction, so it's turned on its side. So if we go here and we add a load, right, we're going to add a load, a force load here. We're going to grab some spot right there and we're going to give it, of course, usually the vector components, and we're going to go y of minus 100 pounds, and we'll see that LB force. That's what I'm talking about. That's what I'm talking about. So there we go. We hit OK, and it's kind of added that force someplace inside there. We, of course, have to go to Material, right-click, Assign Materials. You're going to have a lot of stuff here. I think the default is something we'd like to just be able to take everything in there. We're going to go in and maybe go ahead and make it PVC piping. I don't know. What I'd like to be able to do is to go through and have the default set. I'm going to go this PVC piping. And what we would like to do, and you're going to see, is to be able to get balsa wood in here, which I've got. I don't know if it remembers it from yesterday. I'm not sure how that's going to work on campus. It's basically something, especially when you're mixing materials, is when it gets interesting. When you talk about reinforced concrete or a combined structure where you've got some tensile things, just look at how many parts it has made. And so learning quickly, and I'm not going to tell you I have the answer here to change what the default is so you don't have to do these each individually. I'm going to pause as I do the rest of these. All right, I've made them all PVC piping. See, it's processing them all right now. Couple of things we've added a constraint on one end. We'll see whether this explodes on me. That's a lot of spinning of my hourglass there. So we'll see whether this, okay. We added a constraint, we added material, we've added loads. We would really like at some point here to do automatic contacts. I think it's what it's going to do. It's going to do bonded contacts where everything is there. So it's computing a lot of geometric stuff. You're going to see when I turn on the mesh results, it should tighten up the mesh around my hole. And this thing, if it's PVC pipe, we'll see how, it's gone through the mesh. We're going to go ahead and right-click and view the mesh. There's my mesh view. It's going to probably take a while to show you the mesh. It should put some extra triangles around that hole there. And realizes I know I skipped one of my general supports there as we kind of went through and mimicked a little bit of that box truss that you saw busted today that Greg worked so hard on this weekend. I'm going to pause this as it's computing the mesh even as we speak. Some of that stuff to see how it works on campus and how this stuff then eventually goes into Revit as well. Remembering the biggest mistake I think that I made here and it's not showing. There's the mesh. And you see what it starts to do around these holes. Sometimes you can densify up the mesh, so it's made some assumptions. It's done a little bit tighter, and it's basically done a mesh. And now we're going to see it's going to do a whole lot of calculation here with a mesh that dense. We're going to now hit simulate. And we're going to run it. We'll see what it does. Again, this was PVC piping, so I'm going to fill this time with this. Somehow in the last week, I believe between Congress and the President, they have decided that they're going to allow drilling. You saw the price of natural gas go up 5% today based on the way we estimate gas. So I remember a time in school back in college in 1978 through 82 where Sergeant Lundy in Chicago would hire and fire 200 engineers and technicians almost at will to design pipe hangers for nuclear power plants. And so those were great jobs. Those and jobs like that are going to be part of this new business. And so this sense of getting going at some point, even as we go into Revit here, with what is possible in Inventor between not only the static but the dynamic is worthwhile. And so when AutoCAD freed this up for students about 6 months or a year ago for free downloads, it did need to change the way we think about things. And so you see this progressing as I fill the time. Oil and gas, Pensacola, they're going to drill off of Pensacola, off the East Coast, nuclear power's back, and there's going to be a whole lot more green power. There's a lot of modeling that's going to be done and construction and all kinds of different stuff. And we're going to see, hopefully, that this got done. And I have no idea what it did in the end, but it did something. And so if we look at that, somehow the bonding or what happened here, it showed a lot of kind of this kind of sense. It looks like, it's hard to say what it did. But that's this general bit of you then have to go back and truth it. So what I'm going to do is for one point here, I'm going to go back to the constraints. And right here, that fixed constraints, I'm going to go to the reaction forces. And in that you see, because this was a cantilever, you see one of your triangulation points. If you remember, this was 12 inches and 100 pounds, and therefore you should have about 1,200 pound inches. And that's what you have. You have a reactive moment of 1,200 pound inches. You have a reactive moment of about 100 pounds force in compared to that. And if you go in the X and Z, I don't know in the end where my forces went straight up and down and where I placed it. But basically, you want to start doing these things and truthing a little bit that in fact it gave you something you expected. So right here, you can see, let's think about the positive and negative moments. And let's see if we can go to left, turn this over there. And if think about it, this was turning about the z-axis, and it was spinning in a negative way, and therefore the reactive moment had to be a positive way to resist this negative moment. If you look about y and x and z, and we'll see if we can turn this thing around a little bit. There you go. If you look at that, we're going to turn z back up to us, and we're going to turn this up the other way. And I'm going to turn it back down. So you start to get this sense that, all right, well, let's see, that was actually causing, this was actually causing a positive moment. So the reaction moment actually should be negative depending on how these things are laid out. So I want to point out that based on X, Y, and Z coming out of the board, right, this spin is a positive spin, so the reactive moment should be negative. So they are using a different set of forces. Now we're going to look here at what these reaction forces are, and it's kind of hard to make these out, but we see the 1200 there. So you do want to do this with cantilevers a fair bit, because you're going to see cantilevers are kind of pretty interesting things, because as you draft them up, you can kind of get a hold of it because it's all in one spot. In other words, this has a reactive moment, a reactive force, and the X and Y and the Z, three-dimensional problem. And so I'm kind of curious what it does for all these reactions, but that's what it gave you in terms of the constraints. Contact pressure, we really don't have much of a contact pressure because we don't have contacts except for these hard ones. So we're going to end up with that. So I want you to realize how powerful Framegenerator is, how powerful just drafting basic lines can be. Even if we have that other stuff around, that is worthwhile, but getting your center lines thought out so you can use some of these programs, particularly when you get into Revit. So thanks for listening. We'll post these out on top of what we did before we left for home. See you later. Bye.